one is the number of new members is greater than or equal to 1/2 the number of old members. So let's see here, that would be 0. 0 would work there in that equation. Say you made the number of old members 2, that would make the number of new members 1. Notice it's making a slope of 2. And that looks weird because it feels like it should be 1/2 up here. It's really because the d is the dependent variable in this situation. So if you multiply by 2 on both sides, you get 2n is greater than or equal to d. And it's really in terms of d for that slope. So up 2 over 1. Then we want to make sure that we have some points that work. So I'm going to take this point here, 10, 0, or sorry, 0, 10, and see if it works. 0 for new members, 10 for old members. So that gives me 0 is greater than or equal to 10. That shows that this is not a solution. And so we're once again back in this portion. Now, in order to figure out what are possible solutions, first of all, actually, never mind, we're not answering the questions yet. Indeed, it asks, based on this graph, is it feasible to do without any old members at all? Well, it's not, because if you had 0 old members, it's only working in this region. And that's not a, solutions with 0 members are not graphed in this system of inequalities. Now, based on our graph, is it feasible? Okay, we already did D. E, shade the portion of the feasible region which the club would make at least $100. Well, it doesn't really help that I already shaded it, so I'm going to have to go ahead and choose a different color. So, for us to make at least $100, we'd have to have this be less than or equal to 100. So we'd have to have 8n plus 10d be less than or equal to $100. Well, we can go ahead and we can graph that. I'm actually going to divide it by 2 right now to make it easier. 4n plus 5d less than or equal to 50. Let's see here, the intercepts that we could find for that would be the portions. 12.5 for n, for 0d, and then if we do 0 for our number of new members, that means we'd have to have at least 10 older members. So let's see here, 10, 11, 12.5, and then we have 0, 10, this portion right here. I'm going to go ahead and take out a straight edge and connect this here to make it more accurate. Give me 1 second. So we want the portion where this profit is greater than. Actually, I imagine we want to know that it's greater than. I actually made a mistake in my original equation here. It said at least $100, but I'm making it at most $100. So we're going to have to make an adjustment here. This is one of the many reasons you don't do things in pen. You go ahead and see if it was at most, at least $100. That means we'd have to have the portion that's away from 0, 0. This is the portion right here that we would have greater than $100. Now it says on F, draw a line on the graph showing the number of new and old members needed to make $160. Is it feasible to make $160? We need to explain. So if we change this equation, I'm going to be over here, and this is part F, and we had 8n plus 10d being greater than or equal to 160. We could divide by 2 off the start, 4n plus 5d is greater than or equal to 40. Nope, sorry, 80. Which gives us the points, 20, 0, and 0, 16. We'll see how 0, 16 is up here. 0, 20 way out here. This is 15, 16, 17, 18, 19, 20. I'm actually not going to graph this here. You see how it'll never intersect this line? The reason why it's not possible to make 160 is because these lines don't intersect, that you must have less than 15 total number of members being hired. Now, ask what numbers of old and new members would earn the maximum feasible amount. What amount would this be? You'd have to find all of the intersections. Now, technically, these are possibilities for the maximum and minimum, these three here, except for these four here, you want greater than $100, and we already see that graphically here, so you only care about these 2 points. Now, these are both points that are intersecting with this line, which is the number of new plus the number of old equals 15. And then this line here, which is the number of new members, is 8. So that makes, if this number of new is 8, the number of old is 7. And here, this intersects with a line, the number of old is 10, which to have them to be 15 needs to be 5. So let's go ahead and see. When we have 5 new and 10 old, that will give us the amount of money according to 5 new and 10 old. So that's 40 plus 100, 140. And then we want to figure out the number of money, the amount of money made from 8 new, 7 old. Well, let's see here. 8 new is $64. Plus 7 times 10 is 70. $134. So that tells us that 140 is the maximum that could be made. Then it asks what the minimum feasible amount the club can earn. We'd have to go ahead and you have to plug those values in. I'm going to continue on to the next example for sake of time, but you have to go find the intersections here, 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 and here. I believe the least you could earn, let's see here, this should be 3.3. 3.3 would be 54. And the only problem with this one that you're going to have in this one is see how it's an inequality here. It's kind of an abnormal situation, so you couldn't technically have this amount here, which is 6.2. You'd have to have 6.3. And that's just kind of an unusual feature here. From this information, I believe your minimum will be at 3.3.